Hi all, so today we are going to solve questions from sets and relations which came in different shifts of Jan 2025 attempt. So today we have total 11 questions which we are going to solve, out of which 7 are easily doable, 4 are moderate, and this is on basis my perception which may vary. So now let's jump on to our first question. Here is our first question now. Our first question says the number of non-empty equivalence relations on the set 1, 2, 3 is equal to what? Now to solve these types of questions, here we have a shortcut. We have a shortcut to solve these type of questions where we have given a set and then we are asked number of equivalence relations. Now number of equivalence relations is equal to, it depends on elements, number of elements we have. We can have 1 element, 2 element, 3 element, 4 element and so on. Now there is a table. To make the table, first of all we will write 1. We will take 1 down as it is and add these two. This will be 2. Now we will take 2 to the third row and add these two. We will get 3. And then we will add these two. We will get 5. And same we will do. We will take 5 to the fourth row. Add 2 and 5. We will get 7. Add 3 and 7. We will get 10. And add 5 and 10. We will get 15. So from here, number of equivalence relation of the set when we have 1 element is 1. And for 2 we have 2. For 3 we have 5. And for 4 we have 15. The last element in the corresponding row of the element is our number of equivalence relation. And this patterns go on. We will use the pattern to make the table as according to the elements we have in the set which is given in the question. So for our case we have 3 elements, so we will take the third row. So from here our answer is equal to 5, which comes in option B. So our option B is correct. And here is the solution and we can see that our answer is correct. Here is the next question now. Our question says, let we have A is equal to this set, A is equal to this set and B is equal to this set. And here we have if our C is equal to x comma y belongs to A intersection B, x is equal to 0 or y is equal to 0, then we have to find the value of this sum is equal to what? First of all, we will plot the outline of set A and B. So we are going to plot our outline of set A with the green and the set B with the white. Now here is our Cartesian plane and where we need to know the graphs of these two. These are very basic graph. So the graph of mod of x plus mod of y is equal to 3 is square, this square. Wait a minute. Is this. This is our graph of mod of x plus mod of y is equal to 3. This point will be 3 comma 0. This will be 0 comma 3. This point will be 0 comma minus 3, and this point will be minus 3 comma 0. Now the graph of mod of x plus y is equal to 3 would be of this type. Now these are some standard graphs of modulus which we need to know, which would be useful in calculate while solving the questions like this in which the graph of modulus is included. Now the green one, which we underline green, is drawn in the color green, and the white one is drawn in the color white. Now from here we can see that our set C is where A intersects B and x is equal to 0 or y is equal to 0. So for C we have these 4 points. So our C is equal to 3 comma 0 minus 3 comma 0, 0 comma 3 and 0 comma minus 3. Now the required sum in the question, is sigma x comma y belongs to C of modulus of x plus y. Now this is equal to for each of the element we will get 3 plus 3 plus 3 plus 3. So this is equal to 3 times 4, 12. So our answer is option D. And here is the solution, and we can see that our answer is correct. Here is the next question now. Our question says, let R is equal to this relation, defined on the set 1, 2, 3, 4, then the minimum number of elements needed to be added in R so that R becomes an equivalence relation is equal to what? Now for an equivalence relation, for R to be equivalence relation, our R should be reflexive, symmetric, and transitive. Now for our R to be reflexive, we need to add elements 1, 1, 2, 2. We have the element 3, 3 inside the R, so we need to add 4, 4. We need to add these 3 elements in R to be reflexive. Now to be symmetric, we need to add 2, 1 and 3, 2. For transitive, we need to add, now when we will pair these two, we will get 3, 1. And if we add an element in transitive 3, 1, then for symmetric, we need to write 1, 3. Let's check for others. 1, 2, where we have in the question. From these two, we will get 1, 3. Here also we have. So from here, our minimum number of elements, which is our answer, to make the R an equivalence relation is 1, 2, 3, 4, 5, 6, 7. So our answer is option B. And here is the solution, and we can see that our answer is correct. Here is our next question now. Our question says, let x is equal to r cross r. Define a relation R on x as this is our relation where we have b1 is equal to b2. This is our typing error. Statement 1 says R is an equivalence relation, and statement 2 says for some a comma b belongs to S, we have our S is equal to this, x comma y are a comma b, represent a line parallel to y is equal to x. In the light of the above statements, choose the correct answer from the options given below. So we have to find that statement 1 is true or false, and same for the statement 2. So for statement 1, first of all we will check that if our relation is reflexive. For our relation to be reflexive, our relation would need to be contain the element a1 comma b1 or a1 comma b1. Now in this case our b1 is equal to b1 is equal to b1, which satisfies the condition. So from here our relation is reflexive. Now we will check for symmetric. Now for symmetric, suppose we have a1 comma b1 or a2 comma b2, and our b1 is equal to b2. We are assuming that we have this element in our relation. So if our relation is symmetric, then a2 comma b2 or a1 comma b1 should also be in relation. a2 comma b2 or a1 comma b1 should also be in relation. Now this is in relation if and only if our b2 is equal to b1. If our b1 is equal to b2, then b2 is also equal to b1. So from here our relation is also symmetric. Now the last check for transitive. Now suppose we have elements a1 comma b1 or a2 comma b2, a2 comma b2 or a3 comma b3. Suppose these two elements lie in the relation. These two elements lie in the relation if b1 is equal to b2 and b2 is equal to b3. Now if our relation is transitive, then a1 comma b1 or a3 comma b3 should lie in the relation. Now this lies in the relation if our b1 is equal to b3. Now if our b1 is equal to b2 and b2 is equal to b3, then from these two we can say that our b1 is equal to b3. So from here our relation is also transitive. Now our statement 1 is true. Now let's look at our statement 2. For some a comma b belongs to S, let the set S is equal to this. Now this is in the relation R. This means that this is y is equal to b, and it says it's parallel to the line y is equal to x, so which is not true. So from here our statement 1 is true, but statement 2 is false, option B. And here is the solution, and we can see that our answer is correct. Here is the next question now. Our question says the relation R is equal to this relation is reflexive, symmetric or transitive. So first of all, again we are going to check reflexive. Our relation is reflexive. We are going to check. Now x plus x is equal to 2x x and this is equal to even. So from here our relation is reflexive. Now we will check if our relation is symmetric. Now our x plus y is equal to even, and now we need to check if our y plus x is equal to even. Now if our x plus y is even, then y plus x is obviously even. So our symmetric is also true. Now for the transitive. Our relation is transitive if x plus y is equal to even and y plus z is equal to even. Now if our relation is transitive, then we need to prove our x plus z is equal to even. From here we are going to add both of these equations. We will get x plus 2y plus z is equal to even. Now our 2y is even, we will take to the right hand side. Even minus even is even. So our x plus z is equal to even. So from here our relation is also transitive. Wait a minute. Our relation is reflexive, symmetric and transitive. So from here we can say that our relation is an equivalence relation. So from here we can see that our answer is correct. Here is the next question now. Our question says, define a relation R on the interval 0 to pi by 2 by x r y if and only if it satisfies this condition, then R is reflexive, symmetric or transitive. Again we are going to use the same process. Our R is reflexive. Now for it to be reflexive, our sec square x minus tan square x should be equal to 1, which is obviously true. It's an identity. So from here our relation is reflexive. Now we will check if our relation is symmetric. Now our sec square x minus tan square y is equal to 1, then we need to prove sec square y minus tan square x is equal to 1. Then our relation will be symmetric. We can write sec square x as 1 plus tan square x minus, we can write tan square y as sec square y minus 1 is equal to 1. So from here we will take tan square x minus sec square y to the right hand side. So this will be 1 is equal to sec, or I will write it as sec square y minus tan square x is equal to 1. So from here, from this equation, we prove that our relation is also symmetric. Now we need to prove that if our relation is transitive. So for transitive, our sec square x minus tan square y is equal to 1. Sec square y minus tan square z is equal to 1. Now we are going to add these two equations, and our sec square y minus tan square y will generate 1. So when we will add these two equations, we will get sec square x minus tan square z. Now we will take 1 to the right hand side. This is equal to 2 minus 1 equal to 1. From this equation, we prove that our relation is also transitive. So our relation is all symmetric, reflexive and transitive. So from here our option B is correct. And here is the solution and we can see that our answer is correct. Here is the next question now. Our question says let S is equal to natural numbers intersection 0. Define a relation R from S to R by R is equal to this, X belongs to S and Y belongs to R. Then the sum of all elements in the range of R is equal to what? Now from this equation we can say that our Y is equal to 2 upon 5 raised to power X. From here we can write our relation is equal to, domain of our relation is n union 0. So from here 0 comma 2 upon 5 raised to power 0 comma 1 comma 2 upon 5 raised to power 1 and so on. So from here our required sum of all elements in range of R is equal to 2 upon 5 raised to power 0 plus 2 upon 5 raised to power 1 plus dot dot dot. Now this is an infinite GP with the first term 1. So this is equal to 1 upon 1 minus 2 upon 5. So from here this is equal to 5 upon 3. So our answer is option D. And here is the solution and we can see that our answer is correct. Here is our next question now. Our question says let A is equal to this set and B is equal to this, then number of elements in B is equal to what? Now here first of all we are going to assume our n as 2, 3, 4, wait a minute, n is equal to 3, 4, 5, 6, 7, 8, 9, 10. So if our n is equal to 2, then our set B would be 1 comma 2. If our n is equal to 3, set B would be 1 upon 3, 2 upon 3. If n is equal to 4, set would be 1 upon 4 comma 3 upon 4. When n is equal to 5, we will get 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5. When n is equal to 6, we will get 1 upon 6, 5 upon 6. When our n is equal to 7, we will get 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7. And when n is equal to 8, we will get 1 upon 8, 3 upon 8, 5 upon 8, 6, 7. Now if our n is equal to 9, we will get 1 upon 9, 2 upon 9, 4 upon 9, 5 upon 9, 6, 7 upon 9, 8. And if our let's count number of elements. 1, 2, 3, 4. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Wait a minute. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Please wait a minute. 1, 2, 1, 3, 1, 1, 5, 2, 1, 5, 3. 1 upon 6, 1 upon 7, 2 upon 7, 3, 4, 5, 6. 1, 3, 5, 7, 1, 4, 5, 7, 8. 1, 3, 5, 7, 9. So from here our number of elements in B, there is no such option as 32. Please wait a minute, we have made some mistake here. N is equal to 2, 1 upon 2, N is equal to 3, 1 upon 3, 2 upon 3. 1 upon 4, 2 not 3 upon 4. 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5. 1 upon 6, 1, 2, 1, 3, 4, 5 upon 6. 1 upon 7, 2 upon 7, 3 upon 7, 6, 1, 3, 5, 7. Let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. We have made somewhere mistake for where which we are getting 2 elements. So 1 upon 8, 1 upon 9, yes, 2, 4, 5, 6, 7. 1 upon 3, 2 upon 3, 1 upon 2, 1 upon 4, 3 upon 4, 1 upon 6, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Here we are getting 11, then 12, 13, 14, 15, 16, 17, 18, 19. Yes, here we have made a mistake. Here we are not getting 5 upon 10. We are getting 1 upon 10, 3 upon 10, 7 upon 10, and 9. Then number of elements in B is equal to 31. So option B is correct. In case making, I have made a mistake in last column, so sorry for that. So from here we can see that our answer is correct. Here is the next question now. Our question says that A is equal to this set. The number of relations on A containing 1, 2, 3, which are reflexive, transitive but not symmetric. Now here we are going to make columns. Reflexive, transitive, and symmetric. Now we want reflexive, transitive but not symmetric. So for it to be reflexive, we need to add 1, 1, 2, 2, 3, 3. For transitive, we need to add 1, 3. And for symmetric, we are going to just write. We need to add 2, 1, 3, 2, and 3, 1. Now here we are asked the of relations. Now, if we will suppose take any one of the symmetric, then we should get not problem. So let's take it. First of all, we will take this 3, 1. Then we will get our relation. Relation is equal to 1, 2, 2, 3, and 1, 3. We are adding 3, 1. We have added 3, 1, comma 1, 1, 2, 2, 3, 3. Now we have reflection. If we add one element, we have some more possibilities for it to be transitive. So if we will pair it by this 2, 3, we will get 2, 1. 1. And if we will pair it with 1, 2, we will get one possibility of 3, 2. So if we will take 3, 1, we are not making it symmetric, but in the try to make our function reflexive and transitive, our relation automatically gets symmetric. So this is rejected. This is rejected because if we will take it, then our relation will become symmetric. Now then we have left these 2, 1 and 3, 2. So here we have 2, 1 and 3, 2. So first of all we will take 2, 1 and now we will not take 3, 2. Let me check it. Yes, we are getting our relation reflexive and transitive but not symmetric. Same if we will not take 2, 1 and we will take 3, 2. And the same if we will not take both of these. Now there is one more option if we will take both of these. Now if we will take both of these, then again we will going to land at this case, because if we will pair 2, 1 with 3, 2, we will get 3, 1. So again it will become symmetric. So this case is rejected because of this condition. So here we have 1, 2 and 3 cases. So our answer is equal to 3. So our answer is equal to 3. And here is the solution, and we can see that our answer is correct. Here is our next question now. Our question says that S is equal to this set is a set of first 10 prime numbers, that A is equal to S between P, where P is the set of all possible products of distinct element of S. Then the number of all ordered pairs x, y with where x belongs to S and y belongs to A, such that x divided y is equal to 1. Now here we are going to take an example. If our x is equal to P1, then our y is equal to, if our x is equal to P1, our y can be P1, P1, P2, P1, P2, comma dot 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 till p1 into p2 into dot 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 till p10. So from here our required number of quadrant there, which is our answer, is equal to 10 times. Now we have written 10 because there are 10 prime numbers. There are 10 prime numbers multiplied by, there are, if we will take p1 necessary, we will take that number necessary, so 9c0 plus 9c1 plus 9c2 dot 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 till 9c9. So this is equal to 10 into, this is our binomial expansion, and this is equal to 2 raised to power 9. So this is equal to 10 into 512, and this is equal to 520. So our answer is equal to 520, and here is the solution, and we can see that our answer is correct. Here is the next question now. In this question we have our set A and our set B. Then we have to find number of elements in A and B is equal to what? Now in the A, first of all we will solve the equation. We can write the equation as log 2 upon 5. Now modulus of sin x into cos x, we can write it as 1 upon 2 modulus of sin 2x is equal to 2. Now this is equal to magnitude of sin 2x is equal to 2 upon 5 whole square into 2, so which is equal to 8 upon 5 square. Now we are going to plot the magnitude modulus of sin 2x. It will be, this is 0, pi by 2, pi. This is pi by 2 and this is pi. Because we are going from 0, pi to pi by 2. We are not pi by 2 here, so this would be open here. Now we will plot 8 upon pi square. This would be aligned with this. This is our 8 upon pi square. Then from here we can see that we have 1, 2, 3 and 4 solutions. So from here, from this equation we have 4 solutions. Now we are going to proceed with this equation. So first of all, our 2x is equal to t. Now here we have modulus of, if our root x is t, this is modulus of t minus 2. So first of all we are going to assume t less than 2. We are going to get t multiplied by t minus 4. Minus and minus will be plus 3t minus 2 plus 6 is equal to 0. From here we will get t square minus t is equal to 0. T is equal to 0, 1. So from here we will put t is equal to 0, 1 here. We will get x is equal to 0, 1. Now we are again assuming root x is equal to t, but it is greater than 2. We are going to get t minus 4. Modulus will open with positive, so minus 3 t minus 2 plus 6 is equal to 0. From here we will get t square minus 7t plus 12 is equal to 0. So our t can check by putting S here. So from M this is equal to 8. So our answer is option B. And here is the solution, and we can see that our answer is correct. So hope you found